Hey everybody, it's Miss Berry. This is going to be the lecture video for section 1.6. I'm going to go ahead and flip my screen around and we'll get started. So section 1.6 is called linear equations in one variable. This section will be pretty easy compared to the last couple of sections that we've done. So it says solving linear equations. There's three possible outcomes when you're solving a linear equation. You may get one solution, you may get no solution, or you may get infinitely many solutions. If you get no solution, the symbol that they use in our book to represent no solution looks like this. It's just a circle with a diagonal line through it. And then infinitely many solutions, they represent that with this little fancy R, and that just means all real numbers. So you can use those symbols on the homework or on the test to represent either no solution or infinite solutions. So let's look at some examples. The first one just says solve the linear equation. So we have 7 times 5w minus 3 equals negative 36 times 2 minus w. I'm going to go through this kind of quickly, so you may need to pause the video so that you can write the problem down. So I'm going to distribute on this left-hand side. 7 times 5w would be 35w, minus 7 times negative 3 would be negative 21, equals negative 36 times 2. I should be able to do that in my head, but that's 72. So that's negative 72. Negative 36 times negative w would be positive 36w. Now your goal is just to get all of your w's on one side, all of the numbers on the other side. It looks like it would be easier here to move the w's over to the right-hand side. All right, so that cancels there. You're left with negative 21 equals negative 72 plus 36 minus 35 is 1. So 1w or just w. Then I'm going to add 72 over. Let's see, 72 minus 21 is 51. Okay, so that cancels. You're left with w equals 51. So this is a case where we have one solution. You can check your answer here by plugging the number 51 back into the original equation for w, but you don't have to check your answer. We will see some types of questions that you do have to check your answer on. Let's look at the next example. 8z plus 3 equals 8 times z plus 3 minus 26. All right, so let's go ahead and multiply through on the right-hand side. Left-hand side is going to stay the same. So 8 times z, that would be 8z, plus 8 times 3 would be 24, minus 26. So 8z plus 3 equals 8z, negative 26 plus 24, that would be minus 2. All right, so move all your z's to one side. So I'm just going to move this 8z over. All right, what happens to the 8z's here? They cancel out, right, on both sides. And you're left with 3 equals negative 2. Now, is that a true statement? No, that is not a true statement. This is a false statement. So if you end up with something that's false like this, then you know that means that there's no solution. So no solution. And again, on the homework, they will use this symbol. It's like a circle with a diagonal line through it. Okay. Then we have 4x plus 3 equals 4 times x plus 4 minus 13. Right, so let's work through this one. Left-hand side is going to stay the same. Multiplying through by 4 over here, we get 4x plus 16 minus 13. Again, left-hand side stays the same. Then we have 4x plus, let's see, 16 minus 13 would be 3. You may be able to tell what's happening at this point, but we'll go ahead and we're just going to move the 4x over. All right, what happens to the 4x's? They cancel on both sides. and you end up with 3 equals 3. Now this is a true statement. So if you end up with something like this that's true, then you know that the answer is infinite solutions. Let's use a different color pen. So we know that the answer is infinite solutions. That means you could plug any number into this equation and it would be true. And again, the symbol to represent infinite solutions is that little fancy R. All right. This is the definition of a linear equation in one variable. You do not need to write this down. I just wanted to make sure that I explained it to you or read it to you. It says a linear equation in one variable, say x, is an equation that can be transformed into the form ax plus b equals 0, where a and b are real numbers and a is not equal to 0. So a is not allowed to be 0 because then it would just be some number equals 0. It would cancel out that x. And it says such equations are also called first degree equations, as x is to the first power. All right, so we have some more examples here. Now, when you first look at this, it looks like a rational equation, but when you look a little closer, there's no variables in the denominator. So that means that this is actually a linear equation, and we can easily transform this, or we can easily get rid of these fractions just by finding the LCD and then multiplying every term by the LCD. So our denominators here are 2, 4, and 4. So our LCD would definitely be 4. So you're going to multiply each term by 4. And that is going to cancel out your denominator. All right, so here 2 goes into 4 2 times. Here 4 just cancels with 4. And then 4 cancels with 4. All right, so we're left with 2 times 5z minus 5 plus 6 equals 10z plus 5. Okay, now go ahead and multiply 3 by 2 on the left-hand side. 2 times 5z is 10z. 2 times negative 5 is negative 10. Plus 6 equals 10z plus 5. Right-hand side stayed the same. Simplify this. Negative 10 plus 6, that would be negative 4. All right, get all your z's on one side, all your numbers on the other side. So minus 10z, minus 10z. What happens to the z's here? Or excuse me, the 10z. You cancel on both sides, right? So you're left with negative 4 equals 5. Now, is this a true statement? No, it is not. This is a false statement. So that means our answer is no solution. That means there's no number that you could plug in to this equation and make it true. Right here, I wanted to throw this one in here. There's nothing special or different about this problem, just besides the fact that it's involving decimals. So I just wanted to do this one with you just in case. Sometimes people don't like the problems with decimals, so I just wanted to go through one with you. So let's multiply through on the left-hand side. I guess I should read the problem to you first. I'm sorry. It's 0.25 times x minus 3 plus 0.08 equals 0.15x. So multiplying through by 0.25, you get 0.25 times x minus, that's going to be 0.75, right? 0.25 times 3. Yep. Plus 0.08 equals 0.15x. Go ahead and combine these two. All right, so I've got my calculator right here. All right, so negative 0.75 plus 0.08 is negative 0.67. So 0.25 minus 0.67 equals 0.15x. Oops, I forgot my x here. Make sure that x comes on down. Now we're just going to put all of our x's on one side. I'm just going to move this one over. It doesn't matter how you do it. You could move the 0.15 and put it on the left-hand side. You get the same answer in the end. So we have negative 0.67 equals negative 0.10x. 25 is 10 more than 15. All right, and then we're going to divide both sides by negative 0.10. It's going to cancel over here. All right, so let me pull my calculator back up. Negative 0.67 divided by negative 0.10. 6.7. So this one just has one solution, and x is equal to 6.7. Okay, let's look at this one. Again, I threw this one in here just because it has this little fraction in here. These are all coming off of the homework. So I have 3 times x minus 2 plus 7x equals 1 minus 2 times x plus 1/2. If the fraction bothers you, you could just change this to 0.5 if you wanted to. 1/2 is the same thing as 0.5. I'm going to leave it as, in its fraction form because, it's not going to make this super complicated for us. I'm going to multiply through by 3 here. So that's 3x minus 6 plus 7x equals 1. Negative 2 times x is negative 2x. Negative 2 times 1/2, let me show you. Negative 2 times 1/2 is just negative 1. So the 2 cancels with the 2, leaves you with negative 1. All right, so let's simplify the left-hand side, simplify the right-hand side, and then we will see if we can get all of our x's on one side. All right, so 3x plus 7x is 10x. Over here we have 1 minus 1, so those 1's cancel. And you're just left with negative 2x. Let's go ahead and just, whoops, let me do that over. Minus 10x, minus 10x, move the 10x over. I don't know why I'm writing the equals out here. The equals goes in the middle. Just habit, I guess. All right, so we have negative 6 equals negative 2 minus 10. That would be negative 12x. Divide both sides by negative 12 so we can get x by itself. And the answer would be x equals 1/2. Because negative over negative makes it positive. 6 over 12 is the same thing as 1/2. All right, so that was the first half of section 1.6. The last half deals with solving absolute value equations. The reason they cover absolute value equations in this section is because they say that they are very closely related to linear equations and they're solved very similarly. So this is the important part right here. So this is what I want you to be writing down. Okay. So while you're writing that down, I'm just going to talk about this part up here. It says some equations are solved by recognizing that the absolute value of any quantity is equal to the original quantity or it's negative, depending on whether the quantity is positive or negative to start with. All right, so basically, if you have absolute value of negative 2, then that's going to be 2. If you have absolute value of 2, then that's just 2. All right, so absolute value 2, you can have 2 things that come out with the same answer. Here they both come out with the answer 2, but one is positive and one is negative. It says, for instance, the absolute value of ax plus b is either going to be ax plus b or negative, and then in parentheses, ax plus b, depending on the sign of ax plus b. So we have to consider both cases. Now, this looks a little bit complicated, but I'm going to show you an example, and it's really not complicated. It's pretty easy. And then this part is very important. I want to highlight the most important part here. It says, a word of warning. The apparent solutions obtained by the method above, this method right here, may not solve the original equation. So basically, it's important to check your final answer in the original equation. So you're going to find your answers. All those answers may not work, and that's why we have to check all of our answers before we move on. All right, so just remember, you must check your answer. Okay, let's look at our first example. Solve the following absolute value equation. If needed, write your answer as a fraction reduced to lowest terms. All right, so here's our rule. Absolute value of x plus b equals c has to be split up into two ways. It's either ax plus b equals c or negative ax plus b equals c. All right, so here we have 7y minus 6 inside of the absolute values. So we're going to split this up in two different parts. We're going to do 7y minus 6 equals 11, so you're not changing anything there. And the second one, you're just going to put parentheses around everything that's inside here, put the negative on the outside, and then finish solving. All right, so we have two equations to solve here. These are just two linear equations. So here I'm going to move the 6 over. 7y equals 17. Divide both sides by 7. I'm going to use a different color pen to cross that out. So the 6 is canceled, the 7's canceled there. And then we have y equals 17 over 7. That's our first possible answer. And then here, we're going to multiply through by negative 1. You could put a little 1 out here if you wanted to. That'd be positive 7y plus 6. Excuse me, negative 7y, right? Because negative 1 times positive 7 will be negative 7. All right, so negative 7y plus 6 equals 11. Go ahead and move the 6 over. Negative 7y equals 5. Divide both sides by negative 7. And you get y equals negative 5 over 7. So those are our two possible answer choices. And we're going to check both of those. So we're going to go over here and check. So let's try y equals 11 over 7. Plug it into this equation. So 7, absolute value of 7 times. Let me see if I can make that a little neater. I'll use a different color. Absolute value of 7 times 11 over 7 minus 6. Let's find out what that's equal to and make sure it's equal to 11. If it's not equal to 11, we know that that is not our answer. Oh, look, I wrote it down wrong. It's supposed to be 17 over 7. My bad, you guys. Let me rewrite it. 17 over 7. Over 7. Okay. The 7's cancel. 7 in the numerator cancels with 7 in the denominator. Then you have absolute value of 17 minus 6. Absolute value, or excuse me, 17 minus 6 is 11. Absolute value of 11 is 11. So that one works. So this is definitely one of our answers. Now let's check our second answer choice. All right, now we're going to try y equals negative 5 over 7. All right, so we have absolute value of 7 times negative 5 over 7. Just plugging in negative 5 over 7 right here, minus 6. Okay, so again, the 7 in the numerator cancels with the 7 in the denominator. Negative 5 minus 6 inside the absolute value. That is absolute value of negative 11. Absolute value of negative 11 is 11. So both of those worked. So those are our answers. Your homework may want you to write them together. So you could do like 17 over 7, comma, negative 5 over 7. Okay, let's do another one. You can see this one is a little bit more complicated. We have absolute value of negative 14y plus 4 plus 8 equals 7. All right, so before we apply any of those rules that we just learned, the absolute value needs to be by itself. So you need to move this 8 over. So absolute value of negative 14y plus 4 equals, that's going to be negative 1. Oh, well, let me explain to you how I can immediately look at this and tell you what the answer is. You cannot have an absolute value equal to a negative number. Let's think about that. It doesn't matter what is inside the absolute value. What's going to happen to it whenever you take the absolute value of that number? It's going to make it positive, right? So there's no way that you could plug a number in here and get back a negative number. So that's how I can immediately look at this and say, oh, well, this has no solution. And what's our symbol for no solution? Just that circle with a line through it. All right, no solution. Absolute value cannot equal a negative number. All right, so it's fine that there's a negative inside the absolute value, but you can't have an absolute value equal to a negative. Okay, so anytime you see an absolute value equal to a negative number, you know that that's no solution. All right, and then the hardest problem of all of this entire section is right here. The reason that this is so hard, or that this is more difficult, is because there's a few different cases you have to consider. All right, so let's think about the way that this could work out. Here we have absolute value of 4x minus 7 equals the absolute value of 3x plus 2. All right, so there's two ways that this could happen. You may have 4x minus 7 equals 3x plus 2. Or you could have negative 4x minus 7 equals 3x plus 2. So just like what we did before when we were solving that first example that we did together, we just set the insides equal to each other. We didn't worry about changing any signs. And then the second part is where you change the sign of one side. So here we changed it to negative 4x minus 7 equals, and then we kept the right-hand side the same. All right, so let's solve both of these. Here we are going to just get all the x's on one side, all the numbers on the other side. I'm going to move over this 3x. Right, so that cancels. And we're left with x minus 7 equals 2. Move the 7 over. You're left with x equals 9. So we'll check that in just a minute. And let's try this side. Distribute this negative. That's negative 4x plus 7. So the 7 goes from negative to positive. Equals 3x plus 2. And we have to move all of our x's to one side. I'm just going to do like this. Move this 3x over. So negative 7x. If you're solving it a different way, if you're moving a different number over, that's totally fine. Then I'm going to move the 7 over. Negative 7x equals, that'd be negative 5. Divide both sides by negative 7. We have x equals, negative over negative makes it positive, 5 over 7. All right, so let's go over here to the side and check our answers. All right, so let's go to a different color and we'll just say checking. Checking. All right, so plug in 9. You can't see the top part of the equation. There we go. So plugging in 9, we get absolute value of 4 times 9 minus 7 equals absolute value of 3 times 9 plus 2. All right, so let's see. 4 times 9 is 36. 36 minus 7 would be 36. Ooh, my camera got all out of line there. 36 minus 7 would be 29. All right, so that's going to be absolute value of 29. That looks like 129. Absolute value of 29 equals, see, 3 times 9 is 27. 27 plus 2 is 29. So yeah, that works. All right, let's check 5 over 7. Plugging it in up here. Absolute value of 4 times 5 over 7 minus 7 equals absolute value of 3 times 5 over 7 plus 2. Might have to scoot this one down to finish. Okay. 4 times 5 over 7 is 20 over 7 minus 7. Actually, you know what? We're going to have to put that in our calculator anyway, so let's go ahead and just do that whole thing in our calculator. Let me see. Trying to make this window a little bit smaller. No, apparently not. I'm going to just put it on the side over there. All right, so 4 times, 5 over 7 minus 7. Let's make that into a fraction. So I hit the math button and then I went to frac. This is negative 29 over 7. Okay, so absolute value of negative 29 over 7 equals, let's see what this side is. 3 times 5 over 7 plus 2. Make that into a fraction. Math, frac, is absolute value of 29 over 7. Absolute value of negative 29 over 7 is just 29 over 7. Absolute value of positive 29 over 7 is still 29 over 7. So yeah, that one works too. Sweet. All right, so let's go back over here and we'll just write our answers together. All right, so we have x equals 9 and 5 over 7. Okay. Now the last thing I need to talk about is some word problems. I'm actually going to do that in a separate video because I have class in like 8 minutes. So I will come back and do a part 2 of this video. And I'll see you guys in the next one.